So I have updated the Git repo, or the GitHub repo for the Eclipse group here. And actually I added, I went through the presentations piece. I've got all of the ones that I could find that we've covered posted there. As soon as I start getting some of the video pieces that we've captured, I'm doing a screen capture now, I'll get that up there or linked in as well. So what we're talking about today, let me see if I can, I guess I had closed that folder. Why am I not seeing it? Let's see if this is the right one. Nope, wrong one. I apologize for this. I think when I moved it into the presentations repo, it actually moved it. So let me go in here and find it. That looks better. So what we're talking about today, one of the things we usually cover every meeting, just to make sure everybody knows, the presentations are open. You know, we put them under the Eclipse public license, which means grab them, take them, do stuff with them if you want. We're not shoving proprietary stuff in the middle of this thing. We're trying to keep it out of company versus project and all that kind of mess. It's technology, so we try to keep it at that level. Shameless plugs, of course. Welcome to Cohesion Force. This is our meeting facility that we use. We're open to other people that want to host this if we find others. Feel free to ask questions while we're in the middle of this. If we get anything long-winded, we'll put it on a shelf and come back to it later. We want to try to get this, we want to be mindful of your time. So to get right into it, the concept here was to use Eclipse technology to generate a logger or a data converter for the DIS, what would you call that? Structure, a protocol, I guess. The EMF, which we've covered a few times here, that's Eclipse Modeling Framework. We created that based on a schema available from the OpenDIS project, which you'll find in the back end of several DIS-related pieces. Yes, sir?
What is DIS?
Distributed Interactive Simulation.
So it's one of the two major distributed simulation protocols that are being used by quite a few projects, both government and non-government. It's the older one. The newer one is called HLA. But DIS is more heavily adopted and freely available.
Right. So we pulled a schema from that code base for the structure of the 1998 spec for DIS. The OpenDIS framework, they also do some code generation from the schema, but it seemed, I looked at it and it seemed to be some pretty interesting tooling based on, I don't know if it was custom things they did. Anyway, I had it over in a EMF model, so I started using Eclipse stuff. I had a previous personal project that I had done working towards the EclipseCon from earlier this year, where I had found a way to take the EMF model and then generate the Avro schemas out of the model. So you don't have to write the secondary thing as well. You just write it in EMF and we gen the schema for the data format out of that. Anyway, that's also up on GitHub.
What's Avro?
Avro is a storage format for binary data using multiple compression schemes that are selectable using multiple languages. If you want to hit it with Python or C++ or C, we're actually able to use that quite heavily on a couple of data formats already. So it's been pretty easy to use. We currently have it implemented in Java and C++ and Python on a project. Xtext. We've talked about Xtext before at this meetup. Xtext is a way to write domain-specific languages. Like if you had your own language that you wanted to do for maybe a kid's robotic thing or something, you know, forward, reverse, go up 10, down, you know, if you wanted a custom language for that, or any existing language, Xtext gives you a way to write a grammar, and it does all the tooling for you. It creates an IDE editor for you with syntax highlighting, code completion. If you've got a type that's defined, you can hit the type and hit F3 and it'll take you over to where else it's defined. Pretty high level, really interesting stuff. We could do that again later if we have more interest. So there are some pieces of Xtext that do code generation, and we have taken that part from Xtext and we're using it in a similar way. That's why I wanted to mention Xtext, because that's where we got a lot of the things that we're using here. Extend, this is straight off of Extend's webpage. Think of it as Java on steroids, I guess. There are things you can do in other languages that are a little more difficult to do in Java. In other words, you'd have to write 20 lines of code to do something, where in Extend basically it lets you do it in 1 or 2 lines. Let's say I've got a list and I just want everything in that list that's of type, you know, A. I can drop that instead of having to do a for each and then if this is this, then do this. I can just say, hey, filter this by this type. And it goes and does all that stuff and just gives me the subset list to operate over.
Java 8 kind of does that too.
There's some places in Java 8. Actually, some of these things are calling it Java 9. But so they've been doing, I mean, this has been out there for a couple of years now. What I like about it is you actually write it in Extend. It's got its own extension to the file. It generates the Java code. So when you start to debug this thing and you're stepping through, you can pick which one you want to step through. You can step through Extend, or if you want to see what it generated as Java code, you can step through that as well, trying to do debugging stuff. So that's what I like about it. So some of the issues we ran into, the way that Xtext works, it takes your grammar and it generates an EMF model behind the scenes. It parses that file of source into an in-memory instance of that model, and then it does stuff on the model. Because after it's got it in memory, that lets it make decisions on pieces of data. It can do things like look up this particular ID, you know, do the linking phase of things. So that's one of the things that they got. But our issue is we already have the EMF model, and I'm not parsing a data file to get all of this, you know, disk specification stuff. So I only need the back half of what they're doing. So another thing we ran into is that Xtext uses Google Juice dependency injection, which if you've never played with dependency injection, it's a whole nother kind of thing, and it's from a procedural perspective, it's almost hard to wrap your head around how this happens. You hook all this stuff up, you put an add inject on some things, and they just show up. And half the time you're not sure where they came from or if it's the right thing, and it's just hard to get used to sometimes. So all of the stuff behind Xtext in the back end of their parser engine, it uses Google Juice, and they actually use it a good bit for dependency injection, where they'll just declare a generator and then say, hey, I've got this and I need this type. And the Juice engine goes through and it looks up and finds what it needs and attaches everything, and then you're off to the races.
Is that similar to Spring?
Similar to a Spring framework, similar to the E4 dependency injection that we're using.
So Eclipse also has a dependency injection piece, and that was one of the challenges when the major release came out, 4.2, 4.3, was because we had conflict because a lot of stuff was being generated using XTend, and so they had to consider that. There is a standard. The standard, the injection that's being used by Eclipse is the standard for the what's the underlying
Equinox or OSGI?
OSGI.
Or,
OSGI.
so some
Google
of
Juice isn't OSGI compliant, but the Eclipse one is OSGI.
right. Some of the differences are the Google Juice framework, as far as I know, does injection one time. When you load the class, it injects everything, and you're off to the races, and you're guaranteed that nothing's going to change in the middle of stuff. The way Eclipse does it, their dependency injection engine, it can dynamically generate stuff. So we've got things in our code like I need to know what the active window is. And when the active window changes, it actually re-injects that piece with a new active window. So you can actually get callbacks and things based on events that happen in your system. That said, Google Juice is faster because it does it one time and then you don't have to do anything anymore. So all of their work is on the load. So that was that. So what we did, there's an interface in the middle of Xtext called iGenerator. If you implement that iGenerator function there, or class, there is one method on there for generate, and that is your entry point. It gives you a pointer to some registered model, and it gives you this other class called File System Access, which has been set up previously. In other words, here's where you're going to put your stuff, and here's the model you're going to use when you generate all your stuff. And from there, that's your entry point to go. Think of that almost as your main for code generation. There was another class called Abstract Generic. Yeah, I'm not even going to say that whole thing. Basically, that middle section, you extend that class and you register that class with the injection engine, and the injection engine turns around and calls that class to figure out, hey, I got one of these and I need to generate this stuff. Do you have anything that does this? And of course, your class is only there to say, yes, here's one of these. So we'll cover that in a minute. And then the other thing we wanted to do, we're not building an IDE for people to go enter a bunch of text and generate stuff and whatnot. We want to actually read in data and convert it or do something with it. So we wanted either a main method or a JUnit test or some main kind of an entry point here. It's not a user-based, user click this button or that kind of thing. So demo time. That's where we actually walk through some of this. So these two projects here, ComDis and or Cohesion Force Dis Generation, those are posted here on this Cohesion Force. If you go to GitHub/Cohesion Force, this Dis toolkit, and then in the plugins directory is the same thing that I'm showing. So you get home, want to play with it, go pull the code, hack at it, find problems with it. There's an issues link up here. There's some things you can do on GitHub to where if you want to have your own version of this somewhere, I don't know why that's still up. Anyway, you can actually fork other people's stuff and get your own copy of it to play around with. And if you fix a bug or something, you can actually generate a pull request, which would come back to us to say, hey, I fixed this. You want to pull that back into your code base. So that kind of thing we're doing that. But so to show you some of the interesting pieces of this, real quick, we'll just go through something like this ecore generator.extend. That's the name of the file. And then there's this implements iGenerator, which is that one interface thing that we had to hook to get our main. And from that point, there's this method called doGenerate, which does all the generation stuff. So we've got our piece split out into several different generators. We've got stuff to generate an Avro schema. We've got stuff to generate a marshaller, unmarshaller, to go from a binary format over to this Avro format. We got a whole bunch of other things that we split this out into. We'll cover some of that in a minute. We've got this other piece. That was that. I'm looking for the one where we actually had to implement or extend that other class. That's it. So this runtime module, that was that abstract class that we had to extend to use the dependency injection. Really, the only thing this thing does, I actually updated this up here to show that this isn't even used. It's just part of the class, and you have to override it. What this does, it says, hey, this eCore generator class, which is our main generator piece, that is used to bind to this particular resource set. And so if right now we're using this on eCore, so that uses the just the standard resource set. If you had some other kind of a scenario resource or a configuration resource or my specific model kind of a resource, if you had some other way of storing your stuff, you could actually tap it into there. It's kind of like with a standard EMF. Right now we're storing things as a XMI. You can also store them as XML. I've got that initial Avro piece that I did. I was storing data as Avro natively, so you never even had to go to XMI. You could go to a compressed format. So that's basically what that does. And then so this generator main, this is the main function that we wrote to actually do the generation. This is your standard Java with the main, static void main, and some argument stuff. This injector thing is the juice injector, and we load it up with this generator module. That's the last class I showed that just has a resource and the generator piece. It's the thing that's going to know, hey, if I got one of these, you give it one of these. And it goes through and figures out what to do. So then what this is doing right here, I'm pulling, it's pretty thin as far as any kind of argument checking or anything like that right now. So we're going to, that's on the to-do list. But had to get something out there quick. So our dis98 eCore file, it's loading that out of the model directory, so let's go check that out real quick. And it's not a small eCore file. It's got dis and then basically all the stuff that you would have in a dis. So like a entity state PDU, it's got, you know, all of your stuff you would normally see. It extends an entity information PDU, which extends you know, a standard PDU. So you got things entity ID, location, dead reckoning parameters, all of that kind of stuff is in here. The only thing that's separate from the actual spec, we have this annotation which you can put on EMF models for a PDU type. Because a lot of that stuff is just extra information. It's not in the spec, so or I needed that actually to grab you know, some kind of a PDU type. If you had your own kind of a PDU, let's say you had some kind of a, let's say you wanted to do a Twitter message or something stupid like that, you could actually define your PDU in here, give it your own message thing, and when we generate the code later, you'd see your own converter, you'd see your own reader, you'd see your own logger, you'd see your own Avro file format, all of that kind of stuff. So that's that piece. This just calls down to this generator, which then grabs a piece out of this eCore file. I'm trying to figure out where we actually do the call. Sets up this piece, does a tool.run. That's where we are. So right here, this generator do generate with the resource and this file access. That is our entry point into the entire thing that's wrapped up in one main method. So if you wanted to put that in a JUnit test, if you wanted to put that in a, let's say if you wanted to write your own Maven plugin to generate a whole bunch of stuff as part of your build, you could do that. The other thing I'm doing below here, there's a tool that comes with Avro to where you can take your schemas and have Avro go generate all of the Java stuff to read and write that schema type. So that's what this piece is below here. We actually are calling that live. The other thing we're doing here is we're using some Apache tools to do a copy directory. So I'm actually copying all of the dependent live jar files into the code that I'm generating. So to start off with, you could actually get rid of everything in that disk project, and it would regen all of that stuff from scratch. So just to jump right into some of the fun stuff, let's see, which part is the fun part? Avro schema generator is probably the most complex piece here, because what it is doing is generating an Avro schema, which is a text file. It's not exactly like an IDL structure. It uses a JSON format, which you can walk through all the Avro training slides and stuff and see how they lay those out. I'll show you what one looks like real quick. Right now I'm generating them into this directory. So if I were to go find my entity state PDU, which is probably the most used structure, you see you got a type name at the top, you got some kind of a namespace, and then a list of fields. The two reception timestamp and source timestamp, those we were able to add. They're not actually in the spec, but if I'm reading things across a wire or from a log file that has that data in there, that's one of the things we were able by code generation to kind of cross-cut and put in that specific place, even though it's not in the spec. So if you wanted to flip to use something different, you could modify the code generation, and all of a sudden those types of things would go away. So everything like protocol version, exercise, all of this stuff, you start scrolling down and you get into like an entity ID, you got a site application entity, the entity kind, alternative entity type, velocity, location, just basically all of that stuff. All of this code right here is generated off of this kind of thing right here. And then after we generate the schema, we pass it over to that Avro tool and say, build us some Java stuff out of this, please. And it goes and puts in the hooks for reading and writing those specific file types. So to get back into the Avro schema generation, the main method that gets called here is this generate Avro method. You'll see these kind of what are these? I'm not sure what that character is. It's in Eclipse. It's a control less than, and it'll pop that character in there. Gillimay. That's the right word for it.
Eclipse is the only place I've ever seen a shortcut for that. So
right, especially on a U.S. keyboard. One interesting thing is that is used in other places. It's one of the, isn't it a UML construct that they use in their documentation or their diagrams?
UML has that as a standard. Yeah. So some tools actually like to do less than, greater than to get it.
Okay.
But Eclipse wants to use the UML.
Basically, it's guaranteed to not be a symbol recognized by a parser. A standard C++ parser, things like that. So that's they needed some way to delimit. Okay. Here's actual text that we're going to put in the file versus here's something we're actually going to call a function, or other kinds of things. So the typical way that you see extend work is this function returns a character sequence, which is basically a string, And anything after these 3 tick marks, between those 2 tick marks, are going to get put into that file exactly as you type them, or you can use the Guillemot, the little, I need to quit pointing at my laptop screen and actually use this. So here, what I'm doing is I'm grabbing this package and I'm going everything in that package, if it's a class, call this method for generate schema. And then I'm actually doing another piece for every sub-package in this one. Let's go recursively call this method again. That way it'll walk recursively through this whole structure and build this out. So some of these places, if we go down into here, one of the things I like about this editor is it actually shows you things like your white space, where you can see the grayed out piece here. When that gets put into this is the piece that the reception timestamp and the source timestamp that weren't in the spec that we added into the schema. And it actually tracks the white space that you're going to use so that you can actually generate code that looks like somebody wrote it. So one of the things we've done is generating Python code. And Python actually tracks whether it's in the current method or out. Instead of using curly braces, you actually indent your code so it knows when to jump out of that function. Good luck trying that with most of your normal, code generation stuff, but this actually lets you track stuff. So if I wanted to actually, move that over another line, or maybe put an extra line in the middle, things like that, it actually tracks what you're doing. So basically, all of this stuff is out there. You can go look at it and go do some, if you got questions on it, ship them back over this way. It took a little bit of time to get used to all of the features that are available, things like that. It's a little easier because you've got, if I do let's see if I was doing a something like this, and so that's one of the things that's nice when you get into the middle of it. What you're looking for, it'll actually pop up and say, "Hey, here's all the stuff that's available for you to iterate over," that kind of thing. So it's a lot easier than just going into it cold. So if I wanted to grab, let's see, what about all super types? If I wanted to do something for all super types of that, the other useful thing in the for method, I can actually put a separator in here, if I spell it right. I may just put that guy. And then down here I can put an N4. And so now inside here I can actually, if I wanted to list all the super classes of this one, which like an entity state PDU, you're going to have an entity information PDU, which extends PDU. There's some structure there, but that actually lets you walk it. And the best part about that separator is, I don't know if you've ever tried to iterate through a list and you're trying to put commas after each one, but then when you get to the end, well, crap, I got an extra comma in there. I got to go remove that one or something. This does all that for you. So it says, hey, give me a list of these, separate them by this value. So it'll do things like that. Let me let's see what happens if I do let me just put something that'll show up. So if I did something like class name, actually, let me change the name of this thing because it's actually a superclass. And then I want a class dot name. Yep. Okay. So let me put more of these. We'll be able to see them easier. So I'm going to save that guy. We'll run that in a second and show how that just pops in and shows you a list of all of the class names. superclass names separated by a colon. We'll throw it away when we're done. One of the interesting things about using this kind of an extend piece for code generation, we've used other methods of code generation. Specifically, there's a project called Excelio, which we've used. Actually, if you go look at that other Avro piece that I've done, that was all Excelio. One of the problems with Excelio is you had to take your model and you had to run another instance of Eclipse with your model pulled in order to get access to that. But this guy is actually pulling it straight out of, I should have an import up here somewhere. So I'm just importing the package, importing all the types I need. So it keeps me from having to launch another instance of Eclipse on top of the instance I've got. And I don't know how much RAM you have on your machine. This one has 4 gig, and when you pass 2 instances of Eclipse, you're starting to starve yourself of certain resources, especially if you also have Facebook open or anything else like that. So up here, I'll close this out, walk down, I'll drop a breakpoint right there. Actually, let me put a breakpoint here because that's actually a line of code. So what I want to go do, I'll show you the debug configuration I've got for this. So where was that? Generated main. So the arguments for this right now, I'm grabbing the current project location, which is available down here. If you were to click this, it'll show you all of the variables that you can pick. All this is doing is giving me a pointer to the current selected project. That way I can walk down and find that eCore file. And then what this is saying is grab the workspace location, and here's that's the actual folder that I want to put all of this stuff into. So if I hit debug on this thing, it'll launch and then go do some stuff and drop me into here. I guess I've debugged this before. Let me go ahead and crank that off. So now I'm in the middle of this guy. So I can check the current class that I'm looking at is something called angular velocity vector. I don't know if that's even going to have a subclass. I guess not. Let me see if I can put a breakpoint there. Maybe not. I'm not sure if it'll actually put a yeah, you'll see the piece down here that's blowing up every time that it's hitting this code right here is not a valid schema. So my piece that goes in and generates Java off of that is more than likely choking on that piece. So while we're at it, I'll go ahead and flip over and see if I probably need to wait for it to finish so I know that I've got a
So one of the key
schema
things
over there.
here, you know, why would you want to generate this schema, and why is the schema so important? Avro stores the schema in the files as well. So any Avro data file that you have has stored with it the schema that's there. So if you imagine if you're working a project and your message set is changing over time, right? If I'm doing everything off of the model, then as my message schema changes from run to run to run, as it might be, when I pull that file open, it's going to have stored with it the schema actually logged into the file with the contents, which is very useful if things are changing over time on you. And all the relationships that's in that schema is there as well.
I don't see my actual resupply cancel PDU, so let's go look at that guy. Oh, I know what happened. I actually have this file where I put workspace location. That is no longer where this file actually, where this project actually lives. Let me see if I can flip over. Do what?
Your debug configuration was ripped out?
Well, since the last time I've debugged, I've pushed all of this code to a Git repo, which moves the project over there. So let me go back to my workspace, open this, VI, wait, what was that one? That was resupply, cancel. See right here, I've got all of that stuff that I just put in. So apparently, resupply cancel is a logistics family PDU, and the parent of that is just a standard PDU. So that's some interesting stuff. In a nutshell, that's what we did. To get back to some of David's questions about why we've done some of that stuff, I'm gonna get out of here. I just take a quick detour. I'm gonna close some stuff so that I've got enough memory. Usually when I run this, I'm hitting some other kind of a cluster. Let me drop into this real quick. So we've been playing around with a tool set from Apache. Well, Avro comes from Apache. The Parquet format, originally created by Twitter, was moved over to an Apache project. I didn't seem to care until I found out that Twitter was converting all of their data to Parquet format, and I think they got a little bit of data. So I was curious on that, so we started playing around with some things like that. Ran into a couple of projects. There's a project called Apache Hadoop, which is a distributed file system, that kind of thing. There's a project called Apache Hive, which actually lets you get to data from if it's stored in these particular file formats, as think of it as a database, a SQL base kind of a thing. Spark, which I have loaded up right here, it reuses a lot of the concepts from Hive to give me SQL access to things, but this thing is set up to actually take any kind of query that I put in, optimize it to push the filter as far down the end of the chain as you can, and then take all of that data up and run it on as many cores as you happen to have. So I've got a couple of machines in a lab somewhere that I know have 48 cores per server, and I got 3 servers in a rack. That's quite a bit of processing power that I can turn loose on some data. So one of the things I've been playing around with, I've got this, I'll show this when I'm in a second. So I created a little CSV file that's posted, converter. I found a set of data from New York City where they had posted data sets for taxi pickup, drop-off, time, location, stuff like that. I was trying to generate some DIS data based on something not sensitive. So I just needed data, and I needed a lot of it. This particular file here, which I'm calling start topics, I copied this from somewhere else. But basically that is a Parquet format. If I do a start topics.count, it'll go off and do some stuff, and it'll tell me there are currently 14.7 million records or entity state PDUs in that particular data set. If I want to know, when I read in that CSV file, basically I randomized a bunch of stuff like entity IDs and all of that kind of stuff. So if I randomized it, what this lets me do, if you see between the quotes here, give me a count from. Before I do that, let me also have to register it as a temporary table real quick. So what I'm doing here is, out of those 14.7 million PDUs, show me all the ones where the entity ID.site is one. So if you think of that full DIS specification with everything from site app entity to entity types to position data to all of that kind of stuff, timing information, you know, I just ran a SQL query against a data set that's just in one big binary file. And so it's going to rip through all of that kind of stuff, go load up. This took 22 seconds last time I ran it. Now it's at 12.9 seconds. It told me that I've got 14,978 instances of that particular PDU in that huge set. So let's say you had several different log files and you want to know what's missing from one of them. In a normal database, I have to move all of those log files over to one place and do all this kind of stuff. With this, I can actually move the query to the data. So I can spin up a Spark cluster on the same machine where that data already lives, and I can ask it questions instead of having to tar up all of that stuff. So let me get out of here real quick, and I'll show you the other thing that the other reason we're interested. Downloads, trip data. So in this directory, I had taken that one set of trip data, which is a text file, was about 2.1 gig. If I go up to, let's see, trip data. Trip data _1. So, I mean, that's basically what the data looks like. It's a big CSV file. There's about 15 of these hosted on GitHub. I'll post the link to that after we're done. So if you want to play around with just an ungodly amount of data, have fun with it. So that's kind of the format of the thing. Trip data, where is this? _1 CSV. So that's 2.3 gig. And after I turned it into Parquet, Avro, and log file, I'm actually generating a lot more data than just in that text file, because I'm actually generating a position, a velocity, and acceleration, dead reckoning parameters, and entity ID, and entity type. There's where I started off with the data set that I picked up at this time, I dropped off at this time in this location, that kind of thing. So if I actually look at the size of these things, the straight binary format is 1.7 gig. When I went down to Parquet, it's less than half of the file size. So that's what that snappy compression is giving you. I mean, you've got the exact same data. You can prove it by going through and dumping it and logging it and diffing it and stuff, but it's half the size. And that's for a fully randomized set using the full value of all the floats and all the doubles available and stuff, because I randomized them from max to min to max. So anyway,
If you think about that, that makes a lot of sense, since a tremendous amount of the data in messages and these types of things is repeated, and you're only changing a small chunk of it, you want to keep it all together. Now, this was a somewhat contrived, generated case, but we've done a similar sort of thing on more measured type data, and you get similar compression ratios as well. So this isn't just because the data happens to be the same, it's just the way these systems tend to work.
So that being said, that's basically a fire hose worth of information on generating code from EMF in a nutshell. Any questions?
One other observation that you might think about here is that he talked about to use Spark there, and there's a third technology called Storm, right? So the ideal is how can we leverage these, clusters of computers or, commodity computers. And Facebook and Twitter and all these guys are using cheap computers with lots of stuff, and they spit all the work out to it and let the compute power manage that. Well, Spark and Storm are two technologies